Alright, so today we're going to get into Lewis structures. I have the steps for writing Lewis structures here at the top of this paper. We're going to go through them and then I'm going to show you a couple examples. So first of all, for drawing Lewis structures, the first thing you do is to count up the total number of valence electrons in the compound. This is important because you need to account for all the electrons. You can't use any more, you can't use any less, so you got to have the right number. Then number two, set up the arrangement of electrons. So of atoms, sorry. So you figure out which one's the central atom, that one's going to go in the middle, figure out what the outside atoms, how they're going to be arranged, and go from there. Things like hydrogen will always be on the outside, and halogens, they'll always be on the outside because they only need one bond. Things that need more electrons will generally be on the middle, on the inside of the Lewis structure. Then once you have them organized, you're going to add bonds, so bond everything. Then the fourth step would be to give outer atoms their octet, so fill it up with a full 8, except for hydrogen. Remember, hydrogen only needs 2, so we don't need to give it 8. And then all remaining electrons, after you give everything on the outside their octet, all remaining electrons go on the central atom. So we will start with NH3, so ammonia. I know N is in group 15, so it has 5 valence electrons. I know that hydrogen is in group 1, which means it has 1 electron, and I have 3 of them. So 3 times 1, 5 plus 3 times 1 gives me 8 total electrons. So I get to use 8 valence electrons. As far as setting up the arrangement, I know that hydrogen can't be in the middle. So since I have nitrogen and 3 hydrogens, it's going to look something like this. Okay. Then I'm going to add bonds. So bond, bond, bond. I generally write lines for bonds. You can write lines or dots. Again, it doesn't really matter. Just make sure that if you draw a line, that counts for 2 dots, or that counts for 2 electrons. So then give the outer atoms their octet. Well, these are hydrogens, so they don't really need 8, because remember that first shell only holds 2, so they're good. So all remaining electrons go on the central atom. So we've used 2, 4, 6 electrons. We need a total of 8, so I have 2 left, and they're going to go right there on top. So there is the Lewis structure for NH3. Okay. Now let's try CO2. So carbon is in group 14, so it has 4 valence electrons. Oxygen, I have 2 of them. It's in group 16, so that has 6 valence electrons. 4 plus 2 times 6 would be a total of 16 valence electrons. Okay, so I know I have carbon and oxygen. Carbon, if it's present, is almost always in the middle, if not always. So I'm going to put carbon in the middle. I'm going to put, since I have 2 oxygen, I'm going to put them on either side. Go through, add the bonds, then give the outside their octet. And then any remaining go on the central atom. 2, 4, 6, 8, 10, 12, 14, 16. Well, I've used all my electrons, and carbon isn't happy because it only has 4 electrons. So this is not going to work. Okay? So this is a point where you've used all your electrons and something doesn't have 8. Remember, everything wants 8. The only things that don't are those few exceptions like hydrogen. But you need to make sure everything has 8 electrons. That's a full shell. That's why we do this. So remember, there are 5 elements: CNOPs, carbon, nitrogen, oxygen, phosphorus, sulfur, that can form double or triple bonds. So if you come to a point where you've used all your electrons and you don't have enough left, or you don't have any left to fill up the last element, or any of the elements, then what you're probably going to have to do, you need to check to make sure both of your elements are in this group, the CNOPs group, and you're probably going to have to make a double bond. So if I get rid of these two and make that a double bond, now I have 2, 4, 6, 8, 10, 12, 14, 16. I've still used 16, but now carbon still only has 6. 2, 4, 6. Okay? So we're probably going to have to do it again. So do that. So now 2, 4, 6, 8, 10, 12, 14, 16. There we go. Carbon's good. And we've used all of our 16 electrons. So that's how that one's going to look. Okay. 2 double bonds on the CO2. Let me make those a little bit darker. Okay. All right, let's do this last one, SF6, sulfur hexafluoride. So I know sulfur is in group 16, so it's going to have 6 valence electrons. I know I have 6 fluorines, each of them, it's a halogen. So I have 7 valence electrons in each one of those. So that's 42 plus 6 is 48 valence electrons. Okay, that's a lot of valence electrons, but it's a big molecule, so we're going to have to do it. So I have 1 sulfur and 6 fluorines. So it's going to look, sulfur is going to be in the middle, and then I'm going to put my fluorines kind of all around it, something like this. 6 fluorines. Okay. Then I add the bonds. So that's my setting up arrangement. Now I add the bonds. 1, 2, 3, 4, 5, 6. Okay. Then we give the outside their octet. So I put 6 extra dots around each of the fluorines. Something like this. Okay. And then any remaining electrons go on the central atom. Well, let's see if we have any. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. So we've used all of our electrons, and that means that we are done. Okay. Sulfur does have an expanded octet here. It has more than 8 around it, but that's okay, because if an element is in that 3rd period or lower, that can happen. So any of those elements that are in the P block over there by sulfur and chlorine and all those, they can have more than 8. What they do is they put them in the empty d orbital that's over there, okay, that those elements have. So that's how you do that. Let me know if you have any questions, and good luck.